Hello everyone, I'm Feysel, first batch HSV member, and today we are going to see a problem that is solved by using sorting. And on this problem we are given list of numbers, and our goal is to remove the same occurrence of a given number from that array, and by doing so we want to minimize the size of array into at least half. So for this one is 12, so our aim, we can call it A, is making the size n into n over 2, which is 6, at least 6, so less than or equals to 6. We can remove any element from the array. When we remove it, we will remove all of its occurrence. So on this case we could remove 2, this and this. We have removed 3 elements, and we could remove 7, and we have removed 2 elements to make the size half. So our goal is to decrease the number of elements we are going to remove from the array and making it into at least half of the size. What we can apply is we can use counting sort to count the number of occurrences of a given number. For this one the maximum number is 9, so we should create, so this represents 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then we iterate through the array and populate the values. So we have 1, we have 3, 2s, we have this and this, 2, we don't have 4, we don't have 5, we don't have also 6, we have 1, 2, 3 7s, we have 2 8s, and we have 1 9. Finally, after calculating the occurrence using counting sort, we are going to sort this array. And after sorting this array, we will get like this. First, this was 0, so 1, 2, 3, 4. Then we have 1, 2, 3, 3. Okay, we have 2 of those. And we have also 1. After sorting this array, we will get this one. For this one, we will start from the bigger occurrence and remove it. So our size is n, and it was 12. After removing this one element, you can call it element, one element, n becomes 9. Still, we didn't reach our goal. We move to the next larger occurring element and remove it. Since we don't get whatever number is going to remove, our goal is to decrease the size. We can remove any element, and we could remove the next bigger element, and our elements are removed are 2, and n becomes 6. Now this is satisfied. So we use 2 elements and remove their occurrence to make this array into half of its size by using minimum number of elements, and our answer is 2. And the total time complexity for this algorithm will be, first we are going to iterate through this array and fill it, this one, so it will take O of n. And second, we are going to have we are going to sort this array, which is R. We can call it R to represent the range. We are going to sort this one, and this will we can use also counting sort for this one, but we can also use another approaches. But for now, I assume I am going to be using merge sort or quick sort, which are n log n, and for this case, since the size is r, it becomes r log r. Then finally we iterate through the sorted one and remove the elements, and this will becomes O of r, and this is bigger in this column, like this is have much effect on the algorithm than this one, so we can remove this one, simplify it, and the total time complexity becomes of n plus r log r. And the space complexity, this is time complexity, and the space complexity is we create a new array which is sized of the r, and we sorted it, so this is of r.